Good afternoon, Ashdeep sir. Ashdeep sir, are you there? Hello. Am I audible? Hello, good afternoon all.
Good afternoon, sir. You are audible.
Yeah, thank you. Thank you for confirming. Ashdeep Singh sir. Hello.
Yes, sir. Yes, sir. Am I audible, sir?
Yes, please, sir. But your voice is a bit low.
Okay, let me just. Am I like properly audible now, or
Yes, yes. Now it's fine.
okay. So I will start the
Just will
session
wait for a
in.
few minutes.
Yes, yes.
Yeah, fine. We'll wait for 2 minutes.
Okay, I will start at 2:06.
Okay. I think we can start, sir. People are joining
Okay,
in a bit.
okay. My screen is visible?
Yes, sir. Yes.
Okay, so welcome everyone. Uh, in the previous four sessions, we got introduction about the ROS, what ROS is, why we need it. Apart from that, we had a brief introduction about the Linux, about the Ubuntu, about the command line interface, why we need command line interface, how we use it, how it is different from graphical interface. Then we had some demonstrations using the Linux command line commands. Then we had an introduction for the ROS2 command line, and we have seen various commands for nodes, topics, services, actions, and I also shown some demonstrations. We also have seen how to install packages, how to uninstall them, what is the basic graphical interfaces, like RQT with help of which we can like make it easy to see our nodes are currently in the use. So today's session will be focused on simulations, particularly simulations in which we want to use ROS. So today I will be covering like what is simulation, why we need, what are the options available to us, like how we decide which simulator we can use, and what are the options and how much they are compatible with ROS. Then and there will be an in-depth discussion about the uh, gazebo simulator, which is also an open source simulator and officially supported by ROS, and we will see it uh, as an standalone system, only gazebo. Then we will go to ROS plus gazebo, like integrate. How do we integrate gazebo with ROS? So, starting, what is simulation? Simulation is creation of a virtual model of a robot and its environment that reproduces physical behavior, sensors, outputs, task dynamics so that designers can predict and evaluate robot performance without using the real hardware. So, first need of simulation is that we cannot always use real hardware, because if something happens, something goes wrong, it comes with a cost, and we don't want to bear that much financial cost, that much losses when we are trying our system, because when we are just building our system, there are many bugs, there are many logical issues, and we don't want to ruin our hardware with those issues. So before going to hardware, we want to try, and for that we use simulations. So basic parameters for which are responsible for using simulation before deploying to hardware are safety, cost and time saving, repeatability, controllability, scalability, sensor and perception development, then hardware in the loop testing. We hardware in the loop means we can control hardware and run simulations both at the same time. Like I can control hardware from the simulation environment itself. So there are multiple types of simulations which you might have heard about, like model in the loop, software in the loop, processor in the loop, simulation in the loop, hardware in the loop, then there is digital twin. So these are depending on our use cases, like what we want to do. So depending on that, we use the type of simulation. So basically, uh, all the simulators have capability to do any sort of simulation, but we just need to establish the communication between them. So uh, if we are focusing on ROS, then there are some simulators which we have the option to use. So first one is the i6sim developed by NVIDIA. So another one is Gazebo, then there is VWatts, then there is Mazuko, then there is Unity. So today I will be focusing on Gazebo as it is officially supported by ROS, and you can check the official documentation of ROS2 also. Then in that documentation there is uh, focus on Gazebo specifically for starting the simulations and using ROS2. So what Gazebo is? Gazebo is basically a simulator which has multiple libraries, multiple plugins. It helps us to create an environment, like we can create a room like environment, then we can create a robot, then we can like perform some task. Like if we have a mobile robot, then we can make that mobile robot move in that room, and the mobile robot will also be having all the sensors which we want to apply in hardware also. So basically it is like an creating a virtual environment of actual application. So Gazebo has basically two components. One is server, one is graphical interface. So we can run Gazebo in headless environment, headless method also, and we can use graphical interface also. So we will be dealing with graphical interface today. So uh, for installing the Gazebo, as we have seen the official documentation of the ROS, there is also the official documentation for Gazebo also. So I will paste this link in the chat so you can refer it later. So one confusion while installing Gazebo is the compatibility, which as in ROS there are multiple versions. Similarly, in Gazebo there are multiple versions. How do we decide which version we have to use? As for using ROS, we needed Ubuntu, and we have to make sure that both Ubuntu version and ROS version which we want to use must be compatible. Similarly, for Gazebo, there are versions available for Ubuntu and the ROS. So we need to choose the right version, as there was ROS 1. Similarly, there was Gazebo Classic, which has reached the end of life and it's not available to use now. Then after the Gazebo Classic, there was uh, Gazebo Ignition for some time. Then it is now the only Gazebo is available, and if you are going to start Gazebo, then I will recommend you to use and install Gazebo Harmonic, even if you are using ROS2 Humble and Ubuntu 22.04. So if you are going to install it, then you can follow the official documentation, and the version you have to use is Harmonic, and you can see there are in same documentation page there are options of choosing the version of the Gazebo. So you have to choose the Harmonic version for installing it. As I have already installed it, you have just, if you want to install, these are just two commands which you have to use and it will get installed. So how after the installation, how do we use it? So as we got the familiarity with the command line interface, as we have seen basic Linux commands, basic ROS2 command line. Similarly, Gazebo also offers its command line, so we can use that for like running the Gazebo, and the basic command is ZZ. So I will open my terminal and let's see what does ZZ offers. So ZZ command provides a command line interface to the Gazebo tools. It offers multiple subcommands like topic, sim, service, SDF, plugin, message, model, fuel, help. So at first I will be what I want to be, I need to open Gazebo. For that I will be using this sim sub command for running and managing the Gazebo simulator. Let's just run gz space sim and see what happens. You can see an interface appears. You can see there is version mentioned Harmonic. So this is the initial interface, first interface. When you start the Gazebo, you can see there are multiple You can see an humanoid, you can see an robotic arm, you can see a car in racetrack. Then there is a quadcopter, tell you environment for the quadcopter. Then there is a warehouse environment with an mobile boat in it. So we will see all of them one by one. Let's first open just an empty word. So this is the empty word looks like. So I will first go to this uh, upper left side and we'll see what does it offers. Then we will see what does this word, this entity tree and these plugins means. So before starting, you can see there are some buttons for running the simulation, for restarting the simulation. Currently the simulation is not running because it is at a stop. For running the simulation, you must have to start it. So at the upper left ribbons, you can see at first there is a box. If I click at the box, you will get a box. So this is the basic way of inserting the objects in gazebo environment. You can see at first there was no box was placed and now there are two boxes. So it is an CPU based simulator and you might face some issues sometimes, and the important thing is to, if you are running gazebo and then you, after your work, then you must close it properly, you must end it properly. Otherwise, if in previous instance is running, then you will get some unwanted results. So if you are getting some issues, then the first option is to just check if the previous instance is running or not. If it is running, then just close it and restart this simulator. Then the second shape is an sphere. So you can see there are some other options like a cone, a cylinder, and capsule. So these are the basic shapes that you can insert. So after that, these 3 point directional and spot, these are for the lights. Like if I just get it, you can see there is a light. It is at a point. Now it is a directional light. You can see how much area gets lighted. Then there is a spotlight. You can see as I am just inserting objects, the entity tree has getting that items one by one. Like first we introduce box, you can see box in the entity tree. If I want to remove it, I can use this entity tree just to remove it. You can see I just got an error, exception sending a multicast message, network is unreachable. Uh, you This is the one of the problems using Linux system. You will often encounter these problems and you have to bear with them. So I will just again start the gazebo simulator and let's just open the word and let's just insert a box. Then let's just insert a sphere, insert light, and from entity tree here you can see all the objects are showing here. So these are the items from the upper ribbon. Now in the lower ribbon there is select mode, which object you want to select. Then there is translate mode. If I want to change the position, like this axis, this axis, and this axis. As per the convention of REP 105, the red, it follows right hand rule, and this red axis means x axis, and green axis represents y axis, and this blue axis represents z axis. So if I just start the simulation, you can see the gravity is enabled. If I want to place it at some place, you can see it is just coming to the ground. So this is very basic part of simulator. As we have seen just the translation part, that we can just move along x-axis, y-axis, z-axis. There is rotation mode also. If we want to make rotations like roll, pitch and yaw, we can do with the help of this rotation option in the lower ribbon. Using the right click, you can zoom in and zoom out, and by holding the middle key of the mouse, you can just do this, like changing the view. Then after this, there is option of taking a screenshot. Then there is option of copying and pasting. So let's just go to select mode and see, after right clicking, what options I am getting at an object. Then there are options of move to, follow, track, remove, copy, paste and view. Like in view option, you can have multiple options. Like if I want to see the center of mass, then you can see a small dot is appearing representing center of mass, and I can use another view options like wireframe. Then you can now see clearly this black and red ball, black and white ball with the axis is representing the center of mass of this object. Now let's just try it with another object, cylinder. If I want to change its view, let's just see how does uh, frames look like. Now let's see another options, inertia. You can see the inertia also. So like if you are in your simulation, if the center of mass is changing, or there is need of, like in simulation mass is changing, for that type of simulations, you can use this view option. There is options of seeing joints also, option of seeing collisions also. So this is the very basic introduction to the options that are possible. In the follow options, you have options of follow and free look. Like if there was a robot in a big environment and it was moving, then you can choose the option of follow it, and the camera for view will be just fixed at an your robot. So you can use that kind of options. Apart from that, you can use copy paste also. Copy paste, you can see you have this basic manipulation options. Let's just remove these. Let's just place a sphere here. As simulation is working and there is no ground plane, you can see there is nothing, no ground is there. So all the objects are going to fall you can see it is falling. So if there is no ground plane, you if you place anything, it will just going to drop because there is no ground to hold it. So the one important thing while uh, starting the simulation is, and first entity that you must have is the ground plane. So you have the option of adding the entities from here also. So let's just, how do we see how do we close it? For closing, like we have previously seen the use of Control plus C, and we can use that here. You can cut it from here also, but I will recommend you to use the command line only. And if you are facing any issues, like you want to do something and that is not happening, then you must check the terminal from which the gazebo was running, because it will show some warnings, show some errors. So it will help you to debug your simulations easily. Let's just run it again, and let's just open an empty word again. Now you can see in the entity tree there is a ground plane, and if I now just place anything, it will be shown here. At starting you will face some issues with gazebo, as it is not a advanced, or you can say GPU based simulator. It is just a very simple CPU based simulator. So you can see the spheres are appearing now. So if you face issues, don't worry, it happens with gazebo. So here at that upper right corner in these three ribbon icon, you are getting multiple options. What are these? These are known as plugins. As Gazebo uses libraries and modular plugins to offer multiple options for simulations. Like the first, you can we can demonstrate this apply force torque plugin. So if I select my object and then I just go to apply force torque and just go down, you can see this interface appears, which gives me option to apply force and apply torque on a particular model, particular link. You can see if I select this, the model is sphere. If I select this, the model is sphere underscore 0. So let's just apply force like 100 Newton in the x-axis. I have to click here for making it applicable. You can see this sphere starts rotating slowly. Now, as I said earlier, the red axis is for the x-axis, and we applied the force in x-axis only, and it is moving. Let's apply some like 50 Newton force in y-axis also. You can see now this sphere is moving in two axes, x and y. Now currently the force is applied at the center of mass. So if like you want to simulate something and the force is not at the center of mass, then you can use this option for that. Now if I just make it 0, like no force is there, let's apply some torque about x-axis, let's say 10 Newton meter torque. You can see the sphere is rotating due to this torque. So this is one of the plugin which helps us to apply forces and torques on the objects in our simulation when we need it. So let's just make it 0 and let's see. You can see it is currently moving because it will stop due to friction only, and in environment we will see in upcoming time how do we uh, use friction based on the material of this object and material of our ground. So there are some another uh, plugins, like there is copy paste entity tree. Not all of are useful. Uh, some are more useful, and it basically depends on the need of the user. So like there is an option of point cloud, there is option of public share, there is option of resource spawner, so there is option of save screenshots, so there is tape measure also. So if you want to do something, you must check in this plugin box what options they are providing with the gazebo itself. So I just open some plugins. Let's see what they do. The point cloud plugin is for the camera. So in upcoming time, I will just insert an mobile board with camera. So we'll see how does point cloud appear. And the another major option is resource planner. So what it does, it offers to insert some models, some words that are already been built and shared by Open Robotics. So like I have the option of picking shelves which is available and I have already downloaded it. So you can see this shelf is coming in my environment. Like let's see, there is another picking bin and I have not downloaded it. To insert it here, I must download it and it will take some time. So you have to wait for that. Now you have to just click it and you can see a big bin is appeared and you can place it anywhere you want. So this is like very basic options of adding the already built models or creating the environment. So you can see there is a sensor also. You can just download it and you can see it is basically an AUV. It uh, takes some time to appear in the environment. So you have to be little patient with this gazebo simulator. So this is a option of inserting the environments. Then as we have seen in ROS, there is like topics for communication. Similarly, Gazebo also uses topics for communication, but ROS topics and Gazebo topics are both are different. Let's just kill the Gazebo and check what another options its command line offering us. So there is option of topics. So if I will insert a robot in the gazebo, so the robot will be communicating the sensors of the robot like a camera will be publishing data on topics, and those topics will be of gazebo, not ROS. So, as a standalone system, Gazebo has its own capability. So, if you don't need to use ROS, you don't want to use ROS, your simulation is simple, you don't have to create nodes, then you can use the Gazebo as itself only. As we've seen in the ROS, there are options with the topics. Similarly, it also offers options under the topic command. You can list topics, you can get info about the topic, you can echo, there is frequency option. Similarly, there is an option to publish a message on the gazebo topic. Now, as we have seen the model insertion from the resource spanner, there is another option of inserting the objects, and which is known as fuel models. Gazebo, you can always check the models from this app.gazebosim.org fuel models. I will just paste it in the chat so you can refer it later. There are multiple uh, options are available, like there is a LiDAR available, there is a box with the ARCO markers. So the images are not available all the time because uploaders don't use the thumbnails, but you have options of using models, you have options of using words. You can see this word was available when we just opened the gazebo. Then these are another words which are available. These are open sourcely uh, developed in open source environment. So like this is an uh, room environment which has some racks, sofa, a person is sitting. So before just jumping to developing models and words by yourself, you can look at the already available models, already available words to use them in your simulation. So how does these words, these models are made? Behind what is behind them? So these are based on SDF language. The gazebo uses SDF for simulations, and let's see what does SDF means. There is an website which has complete documentation on SDF. I will just paste it in the document in the chat box so you can refer it. So what is SDF? It's a simulation description format. It is based on XML format, and you can model robots environments using this SDF. And in specification you can see how and what rules we need to follow and what options this SDF offers us. So there is model, scene, state, fix, light, actor model. We will see what does these mean. So we have to choose the right SDF version, and as we are using Gazebo Harmonic and it uses SDF version 1.11, so you need to make sure if you will try to open a word which uses SDF version 1.12, then it will throw you an error. It will not open the word. So as there are multiple words already available in this portal, you can download any word like this word. You can download it. You can directly insert in your code where you have written using SDF. So if I just download it, it will take little bit time, but you can see there is a Jetty word. We have downloaded this, and let's just see what it holds. You can see there is a file named jetty.sdf. This is the file which is responsible for creating a word in Gazebo. You can see it at first it uses XML. So SDF is based on XML language, which is uh, basically a markup language which uses tags. If you are familiar with the HTML, then it appears similar to that. You can see there is a tag named plugin. So it is based on tags. If you want to insert or use something in a tag, then you must have to take care of opening and closing of that tag. So at first there is a mention of XML language, then there is mention of SDF version, as it is 1.12 version and we are using a harmonic simulator, so it will not open in R version of Gazebo. So after that there is are some plugins. What are these plugins? These are physics based plugins. These use basically these solve differential equations based on the collisions, based on the visuals. So this is the back end basically. We need to uh, no need to go in much depth about these. These are the plugins offered by Gazebo to make these simulations like to make simulations much more real. Then after that there are another tags, like you can see there is a tag of light, then you are mentioning a pose, then you are mentioning the intensity of the light, then there are some another parameters. So when you will start development, you will get much more familiar with this. So it is like bit much more complex topic if you want to like create your own Gazebo word. Now we are just talking about the word. Then there will, after that we will be discussing how to write a robot model in SDF. So you can see they have included some models and they have just using the URI, means they are simply using the link from this fuel portal and mentioning the name they want to give and the pose at which position they want to insert it in their word. So you can either download the models, download the word. If you don't want it, then you can just include it also using these tags. It will take some time if you are including, because it will have to ultimately download it from this portal. So little you have to be a little bit patient with this. So let's just I already have downloaded some models. So this is uh, an environment. Let's see if you are downloading an SDF, how to open it. So let's just go to the directory where these are downloaded. You can see an SDF file is present here. For running an SDF file, you have to use Gazebo sim and the absolute path of the file with the file name. As we are already in the directory where the file is present, we have to use just the name of the SDF file and just enter. Let's see. You can see it is opening little bit slowly at the first time. It takes some time. You will often see this force quick and wait for responding when you are opening the new words. You can see it is a warehouse environment. It is having pallets, fans, cans. So as per your need, you can also create this by yourself. If you don't want to, you can adjust with the available options you have. You can see there is a robot present also, and it has the sensors like LiDAR. This is a tugboat robot. So you can see the light from LiDAR. They have just simulated it. You can see how a word and a robot appears in gazebo. Let's just check if there are any topics, or we can see any more information about the sensors, about the robot from the command line. Let's just open a new tab in the terminal, and let's see. Now you can see we have to use this topic subcommand. Let's see what subcommands are there in under the topic. There is a list command. So let's just check what topics are available. You can see a huge list is appearing. You can see as it is simulation, it is based on some time. There will be a clock. Then there are topics related to graphical interface of the gazebo. Then there are some topics related to model. You can see there are models, there are topics related to this model odometry, pose, its transformation frame, then topics which are communicating the uh, battery related information of the board. Then there are some topics which are related to the word itself. So you can always before jumping to ROS, you must know what topics does gazebo have, because for like interfacing gazebo with ROS, you have to interface these topics only, as it is a simulator, and uh, the robot is appearing in the simulator. So if you want to see the data of like this topic battery state in ROS, then you must map it. As we have seen in the ROS, they offer some custom message types for users, and we already use multiple packages which are already developed by them. So they have already the multiple message types. Similarly, Gazebo has multiple topics, and each topic has a message type. And in as we seen yesterday, in message type there is a data structure which must have to be followed. So for mapping, we need to use ROS Gazebo bridge. So let's just see the documentation of the ROS Gazebo bridge. I will just paste it in the chat so you can refer it. You can see what they are sharing with us is the message type for the ROS and the message type for the gazebo. As we have seen in ROS, we can know what type of topic it is, and what data structure they are using. Similarly, using this uh, gazebo command line, we can see that also. So it is like very basic introduction. These all topics holds depth when you start simulation by yourself. Let's just see what does this topic holds using this info subcommand, and you have to see this also. This is the basic requirement for running this info command, that you must mention the topic also. Well, let's just see what does it has. Z is a topic and info, then topic, then topic name. Let's just see this command velocity topic. You can see there are no publisher or subscriber on this, but you are getting the type of the message it is using for communication, and this is zz.message.twist. So you have to find it in the list, and here it is. For mapping this topic, you have to map it with this ROS topic, basically ROS topic type. So for that we use launch files. So it will take much more time and much more depth. We have to understand launch files before jumping to this bridge in detail. So this is very basic introduction about the world, about the robot, and let's just see an SDF file of a mobile robot, and I will just give a brief introduction to the various components. I have already downloaded a SDF file for a tugboat, which is a mobile robot. You can see it is based on SDF and XML. So first tag is the model tag. All the components of one particular model, like a robot will be a model. You have to name it. Then there will be multiple links. It is, you can see it like an tree structure. There is a root. Root is the model. Then there are multiple branches, and all these branches are links. So you have to divide a complex system into the links. So you can see there is a base link. So as we are doing simulation, you have to mention inertia, you have to mention mass. Apart from that, there are two major components of a link. One is known as collision and another is known as visual. So collision is responsible for simulation. All the simulation that we have seen in the Word SDF file, there is mentioned physics tags. Those physics tags, those equations use this collision tags, and you can see there is an STL file mentioned when you are like designing a robot in SolidWorks, or you are designing a model, then you can export it into the STL format, and you have to provide it for the collision tag. Similarly, there is a visual tag, and you can see it uses .dae format because it holds the colors and texture information, while STL does not. So visual tag is responsible for how do we want our robot to look like. So it is basically for visualization, for colors, and collision tag is responsible for making our simulations much more real. So often in complex simulations, you will see this STL will not be used. Rather than that, they will be using some simpler shape, like they can be using a box shape to make the uh, computation easy, because uh, these meshes are much more complex and it will take much more CPU power to and make the mm, simulation much more complex. So there are we have seen collision tag, there is a visual tag, and in the visual tag there is a material tag also. So if you don't have DA file, or you want to use STL in the visual also, then you can manually specify the material, the colors. You can always refer STF format website for the help, and you will have to take care of which tags should be under which tag. So you have to follow the given hierarchy, given syntax. So you can see there is another link, and we just divided the complex system into the links. Then how do we join them? We join them using the join tags. You can see there is a child parent relation as a tree, and you have to mention the type of the joint. It is there are multiple options. It can be a revolute joint, it can be continuous joint, it can be prismatic joint, it can be a fixed joint. So the when you start the development of the robot for simulation or for actual use from SolidWorks or AutoCAD, so you have to divide it into the uh, links one by one. You design them one by one, like you can see as in assembly we design single parts and we just assemble them. It is like that only. We are just dividing it into the links and making it a model, and using multiple models we are creating a word. As we seen in the word file, they have used the include tags to insert multiple models. So at basic we start with the models by combining links and joints, and using multiple models we make a word in the SDF format for gazebo, and different simulators use different extensions, different formats for creating the environment, for creating the model. So uh, it was very like fast and very overview for the gazebo. It has much more depth and much more options, but as time is over, we can go into that. But I shared the uh, reference links. If you want to go to depth, then you must follow these documentations for official gazebo, then STF, then there is a ROS gazebo bridge, and yeah, the official documentation has multiple tutorials like building your own robot, moving the robot, inserting models, inserting URDF, and how to integrate it with the ROS. Then it has also the guide how do we simulate sensors. As we've seen, there was a lidar on the robot, and how actually uh, what actually we need to do while we are writing our files for the simulations. So if you have any query about gazebo or simulations, then you must ask.
Yeah, dear participants, if you have any queries, please unmute yourself and ask your questions. Sir, just one request from our side. So can you
Yes,
just
sir.
showcase some of the simulations you have done? or any project you can showcase to participants?
Actually,
If you
I
have
need to
any.
check because I use multiple, like now I am developing based on Ubuntu 24. Let me check if
Mhm.
I have something on this system, then I will just
If you
quickly
have, then
show. Yeah, just give me 2 minutes. I just
yes,
have to
yes,
check.
please.
Yes.
Meanwhile, participants, if you have any queries, please uh, ask to sir.
So I have just few simulations. I have a simulation of an warehouse bot, so I will just show it. So it uses multiple launch files. So I'm just launching my first launch file. To launch. You can see this is the one of the simulation that I was working. So I just developed some house out of structure. So this is like under development at very basic level. So if I try to open another simulation, then I think you can see this simulation is opening. It is a campus environment. So it is just using one file. I am just launching an environment in the gazebo. Then I will swap my robot using the another launch file. You can see there is an robot. If I just start my simulation, you can see this is a mobile robot named Husky A200. This is its lidar. This is its camera. So I was showing you about the plugins. Let's see if we can see it. You can see blue rays are coming. These blue rays are from this lidar. So let's just quickly see the ROS2 topics which are available. You can see there are some topics which I already mapped from the gazebo. There is topic named command velocity, there is GPS, there is image related topics, then there is ODM, then there is topic related to the lidar. So these are mapped from gazebo to ROS. And if I just open another plugin which is teleop, you can see the robot is moving because I am publishing data on the command velocity topic and I can control it. This simulation was a part of a big project. So the project was to autonomously navigate this robot. So currently we are working on it. So if you need to ask anything from this simulation, you can ask how it is happening or if any particular information about this component. So this was like very basic way of describing the simulation. So any queries?
There is one question in chat box, sir.
Okay.
Uh, Let me.
Automated guided vehicle, what will be the difficult process for it? Okay. Like it, you are working on AGV, then uh, I will suggest you to first develop fundamentals for the ROS and at first tell me what you want to achieve with it. You want to create an robot by yourself or you want to use already built robot. You are working on its navigation or like what is your basic purpose of this automated vehicle or you have any some constraints and then yes
Yeah, Amit
Amit.
Nijat, if you can elaborate, you can unmute yourself and you can just ask your questions. Are you there, Amit?
If you are not available, you can contact me on GitHub and we can discuss what do you want to do and we can set the flow of the process.
Yeah, any other question? Good. I think then we can stop over here today. If you have not
Okay, sir.
no questions.
Okay.
Yeah, thank you, sir. Thank you for all the sessions. All the
Okay,
sessions
sir.
were excellent, sir. So you started
Thank you,
from the
sir.
hands-on Linux installation to the final gazebo simulation. So it was a very wonderful, sir. We also got to know a few of the things. Thank you, sir.
Thank you.
Excellent
It
sessions.
was also a wonderful
We would
opportunity
like to
for
invite you
me.
offline now, sir, for our students, wherein you can give an offline
Yes, sir.
sessions.
We will figure it out. So we'll
Yes, sir. Yes.
see. Yes, definitely we'll see it.
Thank you. Thank
Thank
you,
you,
sir.
everyone.
Yeah. Thank you.
Thank you, sir.
Yeah, all of you can leave the meeting now. So we don't have any session today, second session. Tomorrow also we'll be having holiday. So on Saturday we'll be having a session as per the schedule given. So please fill the feedback form given in the chat box. Okay. Thank you all of you.